Okay, let's get started with this. So welcome to the higher class. Just get set up. So we'll be covering a range of different questions. It is applicable to all exam boards. So you did say OCR doesn't have the Venn diagram questions, but there's other ones that are covered here anyway. And we'll try and go through as much as possible. So let's jump right into it. So I know for Edexcel, they've not tested you on a Venn diagram for paper 1 and paper 2. So there's a high chance it could come up. But it still can come up on other exam boards as well. So we've been given a universal set, so numbers between 1 and 10. We've got set A, which is all the square numbers. So let's list all the square numbers. What are the square numbers? We've got 1 squared, which is 1, 2 squared, which is 4, 3 squared, which is 9, 4 squared, which is 16, but we don't need 16 in this case because our universal set only goes up to 10. So that's set A. Let's look at set B. Set B is all the odd numbers. That's 1, 3, 5, 7, and 9. And we don't need 11 because 11 is not in the top set. So complete the Venn diagram for this information. Let's first identify what's both in set A and set B. So I can see 1 in both of them, so I could put 1 in the middle. I can see there is 9 in both of them. I can put that in the middle as well. Then let's put in the remaining. We've got 4 for set A, we've got 3, 5, and 7 for set B, but we've still got numbers that are in this top set that are not part of set A and set B that need to be on the outside. So let's just cross what we've written so far. So we've done 1, we've not done 2, so that goes here. 3 we have done, 4 we have done, 5 we've done, 6 we've not done, 7 we've done, 8 we haven't done, 9 we've done, and 10 we haven't. And then just double check you've got all the numbers you're expecting. So the whole set had 10 numbers. We should have 10 numbers on this Venn diagram. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, perfect. So that's a nice easy 3 marks for that. Part B says a number is chosen at random from the universal set. Find the probability that this number will be in the set A and B. So this sign here just means and, so it's both in set A and set B. So for set A and B, it's just these 2 numbers in the middle. So the probability is 2 out of how many numbers are there altogether? That's 10. So you'd get the mark for leaving your answer as 2 over 10, or you can simplify it and you can say 1/5. So you'd get the mark either way, but I would always recommend simplifying any fraction that you have in your paper. Just to note as well, so the N sign means and. If it was a U, so A or B, so that sign, that just means or, so it could be in set A or B, so it would be. So in that case, it would be everything in A and B, including the middle. So that would be 1, 2, 3, 4, 5, 6, 6 out of 10. So just make sure you know them 2 notations, the and the or. Okay, so that's Venn diagrams. Moving on to question 2. Matt wants to invest £8,000 for 3 years. He can choose between Bank A and Bank B. Which bank will give Matt the most interest after 3 years? So for 4 marks, this was on a higher paper. So we've got Bank A, we've got Bank B. I think the most important thing as well is how you show you're working out in the exam, which I think a lot of people, their working out is quite messy and then the examiner doesn't really know where to give you marks. So try and keep it as neat as possible. Let's see with Bank A what he will get. So the compound interest formula is always the starting amount, which is £8,000, times our multiplier. So for 1.2%, our multiplier is 1 plus 0.012. So we've got 1.012. That's our multiplier. So it just basically means it's 1.2% more. To the power of how many years? So it says for 3 years. So if we put that in our calculator, we get £8,291.47. So that's how much he gets for Bank A. Let's have a look for Bank B. So it's 2% compound interest for the first year, and then 1% compound interest for every year after that. So the equation will be a bit different this time. So £8,000 times our multiplier for 2%, which is 1 plus 0.02. So we've just converted that 2% to a decimal, adding it to 1, that's 1.02. And because that's just for 1 year, we're doing it to the power of 1, which you don't really need to write down, but I'm just going to write it down here just so it's explicit why there's a power there. Now, for the remaining 2 years, it's 1% compound interest, not 2. So we need a new multiplier. We need 1 plus the 1%, so 0.01. So that just gives us 1.01. So that's our multiplier for the remaining 2 years. So we're doing that to the power of 2. So you can see here, these two powers add up to 3 years, which we're expecting. So putting that in the calculator, we get £8,324.02. So remember, always round these to 2 decimal places because it is money. How did I get 1.012? Because 1.2% as a decimal is 0.012. All you have to do is just do 1.2 divided by 100 just to change it to a decimal, and then you add that to 1. So that's how I got that. So it says which bank will give Matt the most interest after the 3 years. Well, you can see Bank B, because he's got more money at the end. So Bank B will give the most. So be quite confident with compound interest. You don't want to be losing marks on these. Why is 1.01 to the power of 2? Because we can see in the first year, it's 2% compound interest. Every year after that, it's 1%. So in the first year, we've got a multiplier for 1.02. For the remaining 2 years, it's 1%. So that's our multiplier because he's got the money in for 3 years. So be quite aware of compound interest. You don't want to be losing marks here for sure. Okay, moving on. Okay, question 3 says a number x is rounded to 2 decimal places. The result is 2.35. Write down the error interval for x. So this is essentially the same as upper and lower bounds. Error intervals are the same thing. So you might have a different way to do it than I do it, but this is the way that I show students. So since it's to 2 decimal places, I'm going to be adding 0.01 to the number and minusing 0.01. So 2.35 add 0.01 is 2.36, and then 2.35 minus 0.01 is 2.34, and then our error interval is the numbers in between them two numbers. So what you can do is you can do 2.34, add 2.35 and divide it by 2 if you can't spot what's in the middle, but it's just 2.345. And in the middle between 2.35 and 2.36 is just 2.355. So that's my error interval. So you put your x here because it's a number x, and that's between 2.355 and 2.345. But remember, with your error intervals, this one here has to be equal to as well. Reason why is if I rounded this number so to 2 decimal places, that 5 changes the 4 to a 5. It rounds up, so it becomes 2.35. But here, this number can't be equal because if I rounded this up, so that 5 changes this to a 6, but I don't want 2.36, I want 2.35. So that's the reason why it's not equal to. So with error intervals, let me just keep this up here, that's the answer. Your first sign here will always be equal to, but the second one won't. So that's our answer. So that's the error interval. Okay, moving on. The diagram shows a solid cone. The height of the cone is 12. The base of the cone has a diameter of 18, which is labeled on the diagram. Work out the total surface area of the cone, give your answer in terms of pi. So first of all, how do we work out the surface area of the cone? We're going to be working out the area of all the faces. So we can see we've got a face on the bottom. So area of a circle is pi r squared. You have to remember this, you won't be given this. And then area of the curved, so the curved part of the cone, they've given us that in the question. So we're just adding that. So we're just adding to the area of the circle the curved surface area of the cone. So pi r L. So this is how we're going to work out the total surface area of the cone. We just need to find out these two and then we're going to add them together. Okay, so let's work out area of the circle first. It's pi r squared, so pi times r squared. We've not been given the radius, we've been given the diameter. So to find the radius from that, we're just going to divide it by 2. 18 divided by 2 is 9. So we're timesing it by 9 squared, so pi r squared. They've said give our answer in terms of pi. So I'm just going to leave it as, so 9 squared, which is 81 pi. I'm just going to leave my answer in terms of pi. Okay, so we've worked out the area of the circle. Let's work out the curved surface area of the cone. So the equation they've given us is pi times r times L. So pi times the radius, which we've said is 9, times L, which is the height, the slanted height of the cone. But we've not been given that, so we don't know what L is here. So we're going to have to work out L. So we've got no idea what is L. So how can we work out L? I'm going to do it to the side over here. What you need to realize here is on the cone, I can form a right angle triangle, like so. On that right angle triangle, if the height here is 12, then the height here is also 12, so they're exactly the same. So that's 12. We know the radius on the bottom is 9 of that triangle, so we can use that to work out L. So I'm going to draw the triangle here. So L is what we're trying to find out. We know the bottom is 9 because that's the radius, and we know the height is 12. So we can use Pythagoras' theorem to figure out what is L. So remember Pythagoras, a squared plus b squared equals c squared, where a and b is 9 and 12. So 9 squared plus 12 squared equals c squared. So I'll just work out 9 squared, add 12 squared. That gives me 225. So c is just the square root of 225. That gives me 15. So C, I shouldn't have really called it C. I'll call it L since it's L in the triangle that I've just drawn. Okay, so I've just used Pythagoras' theorem to find out what L is, and we've found out that it's 15. So I can now substitute it into here. So 15. So 15 times 9 gives me 135 pi. So the total surface area is going to be the area of the circle, which is 81 pi, plus the curved surface area of the cone, which is 135 pi. They've said give your answer in terms of pi, so we're just doing 81 pi plus 135 pi. So 81 add 135 is 216 pi, and then our units would be centimeters squared since it's area. So that's a nice 4 marker. It's testing you on Pythagoras as well. So just remember, surface area of any shapes is the area of all the faces, and you add them all up together. The volume tends to be the area of the bottom face and then times by the height. Or if it's not that, they'll give you a formula. So for example, they're giving you the formula of the cone here. Okay, moving on. Hopefully that made sense. Okay, question 5. Says the equation of line L1 is so-and-so, and the equation of line L2 is so-and-so. Remember, when we've got equation of a line, we always want it in y equals mx plus c, which is good for that one. But for this one, we don't have it in y equals mx plus c, so we probably will need to rearrange that. It says show that these two lines are perpendicular. So remember, from the y equals mx plus c line, m is the gradient, so the slope of the line. So whether it's steep, not steep, and so on. And c is the y-intercept. So to prove that two lines are perpendicular with each other, i.e. they meet at a right angle, we need to show that the gradient is the negative reciprocal of each other for both of these equations. So let's look at line L1. We've got y equals 5x plus 1. So therefore, we know the gradient is just 5. So it's a number in front of x because we've already got this in the form y equals mx plus c. Let's have a look at line L2. We've got the equation 10y plus 2x equals 9. So we need to rearrange this and make y the subject. So let's minus the 2x first. And then I need to get rid of this 10 that's next to the y. Since it's 10 times y, I need to divide by 10. So y equals minus 2 over 10, which is minus 1 over 5x, and then plus 9 over 10. So now I know the gradient is minus 1 over 5, so it's just the number that's in front of the x. So I can see clearly that these two lines are perpendicular to each other because the negative reciprocal of 5, remember 5 is 5 over 1. The negative reciprocal is you flip it over, so 1 over 5, and then you put a minus sign in front of it. But that's not enough to get the marks in this question. You can't just say like a sentence like minus 1 over 5 is the negative reciprocal of 5. What you have to write, so what it says in the mark scheme is, you have to say 5 times minus 1 over 5 equals minus 1. So therefore, it's perpendicular. So the examiner wants you to write, when you times both of these gradients together, you get minus 1. So that shows that they're perpendicular. So that's how you do that question for 2 marks. Remember, if you're showing that two lines are parallel, the gradient should be the same. Okay, so that's that one. Let's have a look at question 6. So it says factorize fully this here. So let's see if there's any numbers that are common or letters common in both of these. Both 2 and 18, well, 2 and minus 18 go into 2, so I can pull a 2 out. And I don't have any common letters because I've got a C in the first one and I've got D in the second one. So let's start the brackets. So 2 times something gives me 2c squared. That's just c squared. 2 times something gives me minus 18d squared. So that's just minus 9d squared. But we've not finished there. The question says factorize fully. I can still factorize this further. So what they want you to recognize is that this here is difference of 2 squares. So the rule with difference of 2 squares, I'm just going to do a simple one. Imagine I had x squared minus 36 and they said factorize. So the way you factorize this is you get 2 brackets. Because there's a minus sign here, that shows its difference. So this rule doesn't work if it's a plus. What you do is you square root the first term. So the square root of x squared is x. And the square root of 36 is 6. And then you put a plus in one and you put a minus in one. It doesn't matter where you put the plus or minus because x plus 6 times x minus 6 is the same as them two swapped around as well. So that's difference of 2 squares. So that's what I've spotted here in the middle. So 2 times, I'm going to factorize this in the middle. The square root of c squared is c. So c times c is c squared. We'll put a plus in one, put a minus in one. And then the square root of 9 is 3. So I can put a 3 in both. And the square root of d squared is just d. So that's how you factorize that one. So a lot of people have lost marks here previously because they've forgotten that they can still factorize this part here, so you can fully factorize going on. So yeah, so don't forget difference of 2 squares. Okay, moving on. So simplify fully, we've got an algebraic fraction here. So what you need to do is you just need to pull out numbers on the top and bottom, and hopefully something will cancel with each other. So on the top, the common number we can pull out is 3 because 3 goes into both 3 and 9. And we can pull out 1x because there's an x squared and there's an x. So the maximum amount I can pull out is just 1x. 3x times x gives me x squared. 3x times 3 gives me 9x. So that's done. And then what can I pull out on the bottom? I can pull out a 6 and I can pull out just 1x. I can't pull out a y because there's no y in that first term. 6x times x gives me 6x squared times 6x times y gives me 6xy. So usually what we're used to cancelling out is these here, but we can't because they're not the same here. But what we can cancel out is we can cancel out them two x's, because an x on the top on the bottom, we can just cancel it out. And we can also simplify this 3 and 6. So what goes into both 3 and 6? Well, 3, so I can divide the top by 3 and divide the bottom by 3. So I get 1 on top. 6 divided by 3 is just 2. So I've got x plus 3, and then I've got x plus y. I don't really need to write that 1 on the top. I can just leave it as x plus 3 on the top, and then on the bottom, 2x plus y. So you would get the marks for that, but you can also write it as x plus 3 over 2 times x, which is 2x, plus 2 times y, which is 2y. So you can write this, or you can write this. You'll get the same marks, but you just need to know that you can't simplify that anymore. That's the most it can be simplified. Okay, so that's a nice 2 marker. Let's move on. Okay, so we've got some bounds now. So we've been told that m equals a square root of p minus t over r. And they've told us the value of p, t, and r to certain significant figures. And it says work out the upper bound of m. Give your answer to 6 significant figures. So before starting this, to work out the upper bound of m, we need to work out the upper bound of the values that's on the top, and we need to find the lower bound of the values on the bottom. So whenever you're dividing numbers and you want to find the upper bound of that number, you always do the upper divided by the lower. That's the rule to find the maximum number. Okay, so what we'll need to do is we'll need to find the upper bound of p and t, and we'll upper and lower bounds of all these values, p, t, and r. So let's do that first. Okay, so let's find out the bounds of all of these. So for p, let's write p here. P is 870 to 2 significant figures. So to 2 significant figures, I need to add 10 to both sides, essentially, because it's to 2 significant figures. That's the significant figure. So 870 add 10 is 880. 870 minus 10 is 860. And then my bounds are in between here. So what's in between 860 and 870? That is just 865. What's in between 870 and 880? That's just 875. So they're my upper and lower bounds of P, the ones in blue. Okay, so we've done it for P. Now let's do it for T. So T is 500 to 1 significant figure this time. So the first significant figure is the 100 column. So I'm going to add 100 to this. So 500 add 100 is 600. And 500 minus 100 is 400. What's in between both of these numbers? Well, in between 400 and 500 is 450. In between 500 and 600 is 550. If you can't spot that, just add the numbers and divide by 2. So I've got the lower bound and the upper bound of T. Now let's do the same for R. So we've got 0.03 to 1 significant figure. So the first significant figure is that point is the 3 in the 0.01 column. So I need to add a 0.01 to this, so I get 0.04. I need to minus 0.01, so I get 0.02. I need to figure out what's in the middle of these two numbers. So for this one, I get 0.025, and here I get 0.035. Okay, so we've got the upper and lower bounds for T, T, and R. Now I need to figure out what am I going to substitute into this formula to get the upper value of M. So let me just do this in a different color. So the upper value of M. So I've got the square root of P minus T. So how can I get the maximum value for P minus T? So what you could do is you could take the upper value of P, which is 875, and I don't want to minus the upper value of T because that will make the value less. I want to minus the lower part of T, so 450, because I want the maximum amount on the top. So that's where this is where people tend to get confused. So because I want the maximum value on top of this fraction, I'm going to do the biggest value of P minus the smallest value of T. Okay? And then on the bottom, we said we're going to divide by the lower of whatever it is. So the lower of R is 0.025. So putting this in the calculator, just put that in the calculator. 875 minus 450 divided by 0.025. So I get 130.3840481. They want the answer to 6 significant figures. So what's the 6th significant figure for me? So 1, 2, 3, 4, 5, 6. This 0 keeps the 4 as is. So it's just 130.384. That's the 6 significant figures. And that's my answer. What exam board is this? This is for all exam boards. Bounds and error intervals you do need to know for all exam boards. Okay, that's question 8. That was a bit of a tricky one because they don't really introduce a minus there, so that might have thrown a lot of people off. Usually we just do it over fraction. So let's move on to question 9. So we're solving something with fractions inside, essentially. So solving, we're basically finding x. Now, the issue is x is in our denominator and we've got fractions. So we don't want fractions. We want to get rid of the denominators. And the only way we can add fractions together using your basic rules, the denominator needs to be exactly the same. So what could I change both these denominators to? Well, I could change it to 2x plus 3 times x minus 2. So I can just times both denominators together to make them the same. So the first one I want over 2x plus 3 over x times x minus 2. Same with the second one, 2x plus 3 times x minus 2. And that's just going to equal 1. So what does our numerators change to? Let's have a look at the first one. We've got 2. And because we've times the denominator by x minus 2, we need to times the top by x minus 2. Okay, let's look at the second one. We've times the bottom of the denominator by 2x plus 3. So I need to times the top by 2x plus 3. So it's 3 times 2x plus 3, and that just equals 1. So now that the denominators are exactly the same, we can combine the fractions together. So we get 2 times x minus 2 plus 3 times 2x plus 3 all over 2x plus 3 times x minus 2 equals 1. I'm going to keep this bit up here so I have space. Okay, so this is what we're solving now. So it's good that we've combined them all together now. So let's expand and simplify. So 2 times x is 2x. 2 times minus 2 is minus 4. Then we've got 3 times 2x, which is 6x. We've got 3 times 3, which is 9. That's all over 2x times x, which is 2x squared. 2x times minus 2 is minus 4x. 3 times x is 3x, and then 3 times minus 2 is minus 6, and that just equals 1. So let's collect all the like terms now. So on the top, we've got 2x plus 6x. That gives us 8x. We've got minus 4, add 9, which is plus 5. That's all over. We've got 2x squared. Minus 4x, add 3x is minus x, and then we've got minus 6, and then that just equals 1. Okay, what can we do now? Can you also use a grid method? Yep, you can use a grid method. So what I just used was FOIL, so I've just done it using the brackets, but you can use a grid method for this as well. Okay, so now that we've got a denominator on the bottom, that we don't want. We want to bring that to the top. So we're going to times this up to here. So we get 8x plus 5 equals 1 times 2x squared minus x minus 6. Now, 1 times all of this just leaves it the same. So I'm just going to get rid of that 1 times. We don't need that. 1 times the bracket would have just left it the same anyway. Okay, so what you should notice now is you've got a quadratic. So, and the reason why I know I've got a quadratic is because I've got something x squared, I've got something x, and I've got a number. So if you've got them three, you know you've got a quadratic. And with quadratics, we always have to equal them to 0 to be able to solve it. So what I need to do is I need to bring everything over to one side and make it equal to 0. I'm going to bring these two terms to the right-hand side because x squared is positive here. So it'll just be a lot easier doing it that way. So I get 2x squared. I've got minus x and I need to minus 8x. So minus x minus 8x is minus 9x. And then I've got minus 6 minus 5 because I'm bringing the 5 over to that side. And that just gives me minus 11. And that equals 0. So this is what I need to solve. You can use factorizing or you can use the quadratic formula. I'm going to use a quadratic formula just so I can show you how to use a quadratic formula. So there's practice there as well. So the quadratic formula is x equals minus b plus or minus b squared minus 4ac all divided by 2a. You'll be given that, so you don't need to remember it. So what is a, b, and c? A is your number in front of x squared, b is your number in front of x, and c is the final one. So a is 2, b is minus 9, and c is minus 11. All we're doing is we're plugging all these numbers straight into the quadratic formula. Now, what I would recommend is not just put everything straight into your calculator because you'll get an error, most likely because you've accidentally made that negative, for example. You can't square root a negative number. So I'm going to do it slowly. So x equals minus b. So b is minus 9, so minus b is minus minus 9, and two minuses together give you a plus, so it's just 9. Plus or minus, we've got b squared, minus 9 squared is 81. I've then got minus 4 times a, which is 2, times c, which is minus 11. Let's do that. So minus 4 times 2 is minus 8, and then minus 8 times minus 11 is just 88. So I've just put that there. And that's divided by 2a, so 2 times a, which is 2 times 2, which is just 4. Okay, so just notice how I'm doing this in parts. I'm not just plugging everything straight into the calculator. How come you didn't do minus 9? Does it cancel out? Do you mean for this part here, Liva? This one here? Why is that not minus 9? Because the equation says minus b, but my b value is minus 9. So minus minus 9, that changes to a plus 9. Minus minus gives you a plus. That's why it's positive 9. That's quite a common mistake people make. If b is minus 9, make sure you change the sign to it. Okay, so we've got 9 plus or minus 81 plus 88 gives me 169. And the square root of 169 is 13 divided by 4. So I get two answers for x. I'm going to get 9 plus 13, which is 22. 22 divided by 4 is 11 over 2. And then I can do 9 minus 13 divided by 4 just gives me minus 1. So it's a lot better practice just to do it all in parts. So you know how you did 81 squared, would you not do minus 9 squared, or does that cancel out? Minus 9 squared is 81. Minus 9 times minus 9 is 81. So when I did b squared here, minus 9 times minus 9 is 81. So that's where 81 came from. And then minus 4 times a times c give me 88. So that's why it's really important doing this in parts, otherwise you will end up getting wrong answers. So we've just solved it for x. We've got x equals 11 over 2, and we've got x equals minus 1. So I would highly recommend going over the quadratic formula for paper 3 especially, because it tends to come up with quadratic formulas. So yeah, that's my two answers for x. So any questions on that one, or shall we move on? Okay, let's have a look at question 10. So here it says make x the subject of the formula. Now this one's quite tricky because x is in multiple places. You can see x here and you can see x here. So that's going to cause us some issues. So whenever you see x or whatever you're rearranging the subject for in multiple places, you just need to get everything that's got an x to one side and everything that's not got an x to the other side. So let's do this one. So first things first, always get rid of your denominator. So I'm going to times it up. So I'm going to times this 2x minus 3 up to the top. So I get a times 2x minus 3 equals 4 plus 2bx. So I've got rid of the denominator first. Let's expand the bracket now on the left-hand side. A times 2x is 2ax minus 3a equals 4 plus 2bx. Okay, so that looks a lot better than the denominator now. So just like I said before, everything with an x to one side, everything that's not got an x to the other side. So I'm going to bring this 2bx to the left-hand side. So I'm going to minus it. So I get 2ax minus 3a minus 2bx equals 4. So let's have a look at the left-hand side. This has got an x in, so that's good. So does this one, but that minus 3a doesn't have an x, so I'm going to bring that over to the right-hand side. So since it's minus 3a, I need to plus 3a to the other side. So I get 2ax minus 2bx equals 4 plus 3a. Okay, so we've got everything with an x on one side and everything that's not got an x to the other side. I'm going to factorize out x now because I need x just in one place. So if I factorize out x, x times something gives me 2ax, that's just 2a, minus x times minus 2b gives us minus 2bx equals 4 plus 3a. Now to get rid of this, since it's x times that bracket, I'm going to divide the bracket to the other side. So x equals 4 plus 3a over 2a minus 2b. And there you go, we've made x a subject. It's just in one place and there's no x's here. So that one's quite complicated. This is how they will assess you with rearranging formulas in higher. So it'll be in multiple places and they want you to just bring it to one side. So hopefully that makes sense. Let's move on to question 11. So it says here, write 2x squared minus 12x plus 23 in this form, where a, b, c are integers. Integers just Can you hear me now? Okay, that's okay. Okay, that's cool. Right, let's continue. So 2x squared minus 12x plus 23. I'm going to factorize the 2 out. So 2 times x squared minus 6x plus 23 over 2. Now, some of you might have learned not to factorize 2 out of the last term, so it still will work that way as well. So there's multiple ways to do this. So with completing the square, if you've got a number in front, completely factorize that out. And then we're just going to complete the square of whatever's in the middle. So ignore that 2 for now. How do we complete the square of the middle? We do x, we half this number here. So half of minus 6 is minus 3 squared. Minus 3 squared is 9, and we minus 9, so that's just the rule you follow. And then we've got add 23 over 2. Okay, so let's simplify this here. So we've got 2 times x minus 3 all squared minus 9, add 23 over 2. That gives me 5 over 2. And then finally, I just need to expand that 2 out. So 2 times x minus 3 squared, I'm just going to leave it as 2 times x minus 3 all squared. 5 over 2 times 2 is just 5. So that's my answer for part A. So that's a bit of a tricky complete the square question. Now for part B, so that was part A. Part B, it says hence or otherwise write down the coordinates of the turning point of this graph. Well, using what we found in part A, all we do is we take the x coordinate from the inside, but it's always the opposite sign. So it's not minus 3, it's 3. And then we take the y coordinate from the outside and we leave the sign as is. So it's just 3, 5. So the turning point for this graph is 3, 5. So this is a U-shaped graph because it's a quadratic. It just means this turning point here is at the coordinate 3, 5. So that's for 4 marks completing the square. Let's move over to question 12. Okay, so it says sequence A is a linear sequence. So a linear sequence means it's something n plus a number. So an plus a number. That's what it means by a linear sequence. It says the first term is 6 and the fifth term is 50. So work out an expression for the nth term of this sequence. So there's a bit of an algebra one. So I know that if I have my linear term, for my first term, it's going to be 6. So essentially, when n equals 1, so my first term, this here is going to equal 6. So a times 1, because n is 1, is just a, plus b equals 6. Now, whenever we've got two unknowns, so a and b, which is an unknown, we need a second equation, so it's simultaneous equations. So when n equals 5, so the fifth term, an plus b would become 5a, because n is 5, plus b, which is 50. So this is what I need to solve. These two equations I need to solve to find out what's a and b, and I'm going to plug it straight into here. So I can rearrange this top one here. I'm going to do it in different color. I can rearrange that. I can make b the subject. So I'm going to minus a to the other side, 6 minus a. And then I'm going to plug this in to b here. So I'm just doing simultaneous equations. So 5a plus b, which is 6 minus a, equals 50. Let's solve this. 5a minus a is 4a, plus 6 equals 50. Let's minus 6 to the other side. So we've got 4a equals 50 minus 6, which is 44. So therefore, a equals 44 divided by 4, which is 11. So I know a is 11n. We just need to find b now. So to find b, I'm going to use this equation up here and substitute the 11 back in. So b equals 6 minus 11. So b just equals minus 5. And that's our expression for the nth term. So that was a bit of a tricky question, mixing simultaneous equations and linear sequences together. But I hope that did make sense.
So the final question now, we've got, actually we've still got 2 more questions, but let's do question 13. It says simplify fully this algebraic fraction. So let's factorize the top. We haven't got any common letters, but we've got a common number, which is 7. 7 times y is 7y. 7 times minus 5 is minus 35. Divided by, the bottom is difference of 2 squares, because I've got a minus sign there and I've got 2 squares. So I've got the y squared and I've got 25, which are both squares. Put a plus in one, put a minus in one. The square root of y squared is y. And the square root of 25 is just 5. What can we cancel from the top and bottom? I can cancel the y minus 5 term. So my answer is just 7 over y plus 5. We don't need the brackets on the bottom anymore. So that's a nice 3-mark question. And finally, we've got a quadratic simultaneous equation question. So it says solve the simultaneous equations. We've got an equation of a circle up here. So x squared plus y squared equals 13. And we've got a linear equation on the bottom. Now, the way we solve these simultaneous equations is we substitute the linear into the ones with the squares in. So since, let me just rub this out. So x equals y minus 5. I'm going to substitute y minus 5 into the top for x, because that's what x equals. In order to solve simultaneous equations, we need an equation that just has just one letter in. That's the reason why we substitute in. So x squared, which is y minus 5 all squared, plus y squared equals 13. So you can see this is all just in terms of y squared, well, y now, so we can solve it. So the first term, y minus 5 all squared, is y minus 5 times y minus 5, plus y squared equals 13. Let's expand this bracket here. Y times y is y squared. Y times minus 5 is minus 5y, and then minus 5 times y is minus 5y, so minus 5y minus 5y is minus 10y. Minus 5 times minus 5 is 25. You can use the grid method for that as well. So plus y squared equals 13. Let's collect like terms. We've got y squared and y squared, which is 2y squared, minus 10y plus 25 equals 13. So because we've got a quadratic, we've got something y squared, something y, and a number, we have to make it equal to 0. So I'm going to bring the 13 on the right-hand side over to the left-hand side. So I get 2y squared minus 10y, and then 25 minus 13 gives me 12, and that equals 0. So this is what I'm solving. Now, to make this easier, since 2 minus 10 and 12 are multiples of 2, I can divide the whole equation by 2. So I get y squared minus 5y plus 6 equals 0. So that's a lot easier to solve than the top one. So I don't have to use a quadratic formula. I can just factorize this one. So 2 numbers at times to give me 6 and add to give me minus 5. That would be minus 2 and minus 3. If you do want to use a quadratic formula, you can use a quadratic formula. You'll still get the answers. So therefore, y equals 2 and y equals 3. We just take the opposite signs. So we found our 2y values, but we've not finished the question. So we're solving it, so we have to find both y and x. So how do we find x? We need to substitute our y values that we found into one of these equations, but I'm going to choose the bottom equation because it's easier. If you chose the top equation, you'll still get the same answer, it's just harder. So when y equals 2, x equals y minus 5, which is 2 minus 5. So x equals minus 3. So I found my first answer of x. We still need to find our second answer of x. So when y equals 3, so we've just plugged this one in here, x equals 3 minus 5, which is just minus 2. And there's my final answers. So that's all for answers for 5 marks. So one tip I would give you with this question is, in the exam tomorrow, they might not give that in a nice format, that second equation here. So if x or y isn't the subject of the formula, rearrange it to make it the subject of the formula. and hopefully that will help. So that's the last question on that one. Hopefully you did find that helpful. There are a lot more questions also covered on YouTube as well. So this session will go onto YouTube, the foundation one will be as well. There's a lot more on here as well that you can go over, and they're all timestamped. So if there's any topics that you're struggling with, there's a lot on here that you can use to help with that. So yeah, I'll wrap that up here. We've got the chemistry class on Thursday because the exam's on Friday. So hopefully see a lot of you there, and I hope you did find that helpful. If you've got any questions, do ask, and good luck with the exam tomorrow.